Now, today's topic we'll be looking at what a computer is. We'll also be taking a closer look at the components that make up a computer and the functions of these components within the computer system. So, ladies and gentlemen, thank you for tuning in. My name is Jeff Boateng. Defined as an electronic and programmable device for storing and processing data, typically in binary form and according to the instructions given to it in a variable program. As you get to familiarize yourself with the key terms mentioned in this definition, I'd like us to take a basic overview of the computer components. So a computer system comprises of two primary categories of components, that is the hardware and the software. The hardware refers to the physical parts that make up a computer. The software refers to the commands that the computer follows when performing a given task. To put it differently, hardware is the physical or tangible parts that are located internally and externally to the computer and help in running the whole device. While the software refers to the set of coded instructions or simply a program that the computer follows when executing a specific task. Either way, both the software and the hardware components are essential in order to successfully operate a computer. But in this discussion, we're going to focus mainly on the hardware components. So a computer hardware comprises of a combination of mechanical, electrical, and electronic parts, which are also divided into four main types of the computer hardware devices. So this includes the input devices, the output devices, the storage devices, and the processing devices. So the input devices refers to the computer hardware components that help you as a user to send data, information, or control signal to the computer for processing. Some of the most common examples of the input devices include the mouse, keyboard, barcode reader, scanner, and so many more. The output devices now refer to the computer hardware devices that perform the task of displaying or delivering the processed data by the computer to the user. So basically what they do is they receive data from the computer, then convert this data into a human-friendly form like audio, video, text, image, or a hard copy. Then give it to the user as an outcome. Monitors, projectors, printers, speakers, and headphones are just but a few examples of the output devices. So coming third on our list, we've got the storage device. And this one is any type of a computing hardware that is used for storing, quoting, or extracting data files and objects. Storage devices can hold and store information either temporarily or permanently. They may be internal or external to a computer, server, or any other computing device. So storage devices are one of the core components of a computer, as they do handle the storage of all the information and applications in a computer, but except now for a hardware firmware, which is a read-only memory or ROM, something that we are just about to look at in this topic. So there are two different types of storage devices, and this one includes the primary memory and the secondary memory. The primary memory or main memory refers to the area in a computer in which data is stored for quick access by the computer's processor. These types of memory are generally smaller in size. They hold data temporarily, they are internal to the computer, and they have the fastest data access speed. Primary memory devices are located within the motherboard, and they are classified into separate types with different purposes and functions. So here I've got a few examples of the primary memory devices that will help us understand what exactly they are. So we've got the read-only memory or ROM that I just mentioned. And this one is a programmable chip that contains most of the instructions that are needed by the computer when starting up in a process known as booting. Booting is such an interesting topic that we'll be looking at in our next video. So ladies and gentlemen, remember to hit the subscribe button and keep it right here. So ROM is an unvolatile type of memory in which all the data stored in it remains saved even after the computer is switched off. It's also good to know that the ROM is not limited to computers only, as these chips can also be found in other equipments like microwaves and washing machines. The reference read only means that data in it can only be accessed by the computer and cannot be changed by the user. The next on our list, we've got the random access memory, or RAM. Something I believe you're most familiar with, especially with the smartphone and other smart devices that you've been using nowadays. So RAM is a volatile type of memory, so once the computer is switched off, all the data and instructions held in it are lost. The term random access means that data can be stored and accessed from any location within the memory. RAM is used to store data which is being currently used by the CPU. So by any open document or a program that is running on a computer will have its data files being held by the RAM, waiting to be fetched by the CPU for processing. So this means that the more RAM a computer has, the more data and instructions it can hold simultaneously. And this is one of the things that greatly enhances the performance of a computer. RAM can be upgraded easily, as most computers come with a removable RAM stick. So you can easily change it with another different or bigger size of a RAM. It's also different from the other primary memory devices, as it can be read from and written to. So apart from ROM and RAM, we got the cache memory. And this one is a temporary high-speed memory that is used for storing data, which is used more often, and the processor can access it more quickly than the RAM. Cache memory holds the information of frequently requested data, so that this data is immediately available to the processor when needed. It also works faster than RAM, as its data travels a shorter distance to the CPU. In fact, even with the modern computers, you find that the cache memory has now been integrated within the CPU itself. So a good example of how cache memory works is when using the internet through a web browser. Cache memory will hold the website's HTML images and other information, so that this page will load more quickly the next time you visit this particular website through the same computer. Human beings, as you have seen, the storage capacity of the primary memory devices is very low, and these types of memory are volatile, as any data stored in them will eventually get lost. So in such a situation, if you wanted to permanently store a large amount of data, then you need a different type of a storage device. So this one brings us to the other type, which is known as the secondary memory. So what's a secondary memory? This is an non-volatile type of memory in which all the data and information stored in it remains saved even after the computer is switched off. Unlike the primary memory, this type of memory is not directly accessed by the CPU, as its data must first be loaded into the primary memory like RAM, where it will later on be fetched by the CPU for processing. So here I've got a few examples of the secondary storage devices that will help us understand how different they are from the primary memory devices. We've got the hard disk drive, or the HDD, the solid state drive, or the SSD, the universal serial bus, or the USB, the compact disc or CD, the memory card, and so many more. The hard drive is what most computers use as a secondary storage device. It is located within a drive unit and is connected to the motherboard through a serial advanced technology attachment connection, or SATA. It is also connected to a power supply unit. So the HDD is used to store data such as the operating system, the installed softwares, and user files such as pictures, music, videos, text, and documents. For decades, computers have been using the HDD, which uses a spinning platter with an arm moving across the platter to read each portion of data. These moving parts has made it to be the most likely component to break or fail, which might lead to a very huge loss of very important data. So due to this reason, manufacturers developed a newer type of a storage device, which is known as the solid state drive, or the SSD. The SSD uses a flash memory to read and write data digitally. It does not have any moving parts, and therefore resulting in a more durable component. And since it doesn't have to mechanically seek out data, SSDs deliver nearly instant boot and load times. Either way, both the HDD and the SSD can serve as your computer's long-term memory for permanently storing your files for future use or reference. move on to the last on our list, and this is the processing devices. But before we get to look at the processing devices, we must first of all understand what data is. And data simply refers to raw information or information that has not yet been processed, while information refers to processed data or data that has been processed. So when a computer receives data through an input device such as a mouse or a keyboard, the data must first go through an intermediate stage before it can be sent as information through an output device such as a monitor, speaker, or a printer. Processing devices is any component in a computer that handles this intermediate stage. And this intermediate stage is handled by various processing devices such as the central processing unit or the CPU, the graphics processing unit or the GPU, the sound card, and the network card. Therefore, processing devices refer to the computer hardware components that carry out the interpretation and manipulation of data into information. Processing devices perform the actual computation and manipulation of data to give us information. The CPU and the GPU are the two main types of the processing devices, and these are the ones that we'll be looking at.
The CPU, often referred to as the brain of a computer, contains all the circuitry needed to process input, store data, and output results. The CPU is composed of several components, including the arithmetic logic unit, the control unit, and the registers. The arithmetic logic unit performs arithmetic and logical operations. The control unit controls the flow of data between the CPU, memory, and input/output devices. And the registers hold the data that the CPU is currently processing. The CPU is constantly following instructions of computer programs that tell it which data to process and how to process it. Without a CPU, it will not run programs on a computer. Like for example, a simple calculator program might instruct the CPU to take two numbers, 2 and 2, and add them and send back the results. The CPU can process those instructions easily thanks to a control unit that knows how to interpret program instructions and an arithmetic logic unit that knows how to add numbers. With the control unit and the arithmetic logic unit combined, the CPU can process much more complex programs than a simple calculator. The performance of a CPU is often measured in terms of clock speed, which is the number of clock cycles per second that the CPU can execute. CPUs with higher clock speeds can execute more instructions per second, resulting in faster performance. However, there are many other factors that can affect the CPU performance, such as the number of cores, cache size, and architecture. A graphics processing unit is a specialized processor designed to handle the complex mathematical calculations needed to create and render images, video, and other graphical content. It's often used in conjunction with a central processing unit to provide a more powerful and efficient system for tasks such as gaming, video editing, and scientific simulations. GPUs have specialized hardware and software designed to accelerate the rendering process, such as dedicated memory for storing and accessing graphical data, and the specialized instruction sets for performing common graphics operations. GPUs are widely used in computer gaming, where they are used to render high-quality graphics and provide smooth gaming experiences. They are also commonly used in scientific research, where they can be used to accelerate the simulations and data processing tasks. In recent years, GPUs have become increasingly popular for machine learning and artificial intelligence applications, where they are used to accelerate the training and inference of deep neural networks, which are a key component of many modern machine learning algorithms.
So, ladies and gentlemen, this brings us to the end of our topic today. I hope you enjoyed and you are able to learn one or two. Don't forget to hit the subscribe button and the bell icon so that you don't miss out on the next topic, and that is the booting process of a computer. Once again, my name is Jeff Boateng, and allow me to wish you a happy